Confirm you are able to see my screen from your end. Thank you. So thank you again for joining this session. This is session 6 for our IPRAN training session. So we've been having these sessions almost after every 2 weeks. Some have delayed maybe after 3 weeks, some after 1 month. But again, we've covered 5 sessions and we started with the general architecture of IPRAN. We went to discuss about the IP address design and also the IGP ISIS design for IPRAN network. We also managed to cover a lab simulation to demonstrate how you configure and troubleshoot ISIS on Huawei devices that you've deployed on your IPRAN network. We also discussed BGP design for IPRAN network, so you need to deploy BGP on your network. We discussed the design principles, which device should be peering to which devices, and all those details, IBGP, EBGP between different autonomous system numbers. And we also did a lab simulation to demonstrate how you configure and troubleshoot BGP in our last episode. So in our today's session, we are discussing a very interesting topic, MPLS for IPRAN network. So before we start this session, do we have anyone who has a question from our previous sessions? Any question from our previous session that we need to respond to from the audience? If you have a question, if you have a comment, you can just unmute and proceed. Have you had any challenges doing the labs? Have you had any challenge understanding the previous topic that we've covered? If so, then you can just unmute and ask your question or a comment or a clarification that you require from our previous sessions. Okay, so that one means we are all good. If you missed any of those sessions, you can find the recordings on our YouTube channel, Life Technologies. We have all those sessions recorded and many other sessions on how to just implement networking on different vendors, Huawei, Juniper, Nokia, and many other sessions will be uploaded to our channel. So, let's start our today's session. I said that we are covering MPLS. And if you are managing, especially for those one who are managing a service provider networks, you definitely have MPLS deployed on the network, whether it's for a carrier network or even for the enterprise network, you definitely have MPLS deployed. So this is what we are discussing. So in this session, we will have like 2 parts. The first part is to introduce you to MPLS. I know not all of us have interacted with MPLS, so we'll be having an intro to MPLS to make you understand how MPLS works, the working principles of MPLS, how does it forward packets, what are some of the actions that are performed when the packet is flowing from one point to the other, and then we look at some applications of MPLS, and then on the IPRAN part, we will be looking at seamless MPLS. Why do we need seamless MPLS on IPRAN and how it's implemented on service provider IPRAN network? So to start us with, we'll start with let me put it in the presentation mode. So what is MPLS? This is just an open discussion to understand the audience and also to gauge what we need to cover in the next few slides that we'll be discussing. So anyone can proceed. What is MPLS? What do you understand about MPLS? Do you have MPLS in your network? What does MPLS, the term MPLS stands for what? Just unmute and proceed, or
Uh,
you can raise your hand. Yes.
Hello, Martin.
Yes.
It's John here.
Yes, John.
Yeah, it stands for multi-level, multi-protocol level switching.
Multi-protocol
In our net,
switching.
yeah,
Okay.
it's a switching technology, which we find between, which sits between the layer 3 and layer 2, and in our network, we do use it for forwarding packets. Maybe more specifically, with the evolution of time, we're now talking about seamless or unified MPLS in our network. That's what we are now more working with, because we have got different segments of our access network, where we need to then also combine them later on. So it then make it seamless across different ASs that we have in our network. So I also work for one of the largest network operators in Zimbabwe, which is Liquid Telecom. Mostly, I work in the network operations center. I was also in the engineering team, and I'm very grateful for what you are doing here as well. Thank you.
Thank you, John. So that is MPLS. I think he has explained a lot about MPLS, what it does, and how they are using it in their Liquid Telecom network. So another question. Thank you for the response, and I'm glad that you all managed to join this session. It's always a motivation for me because you guys are always very supportive. That's why I still conduct these sessions. And just to share the knowledge that we have, the knowledge that we are using out here to make everyone familiar. So another question that we need to discuss is which layer of the OSI TCP model does MPLS protocol belong to? So we know we have the OSI, the 7 layer, and then we have the TCP IP model. And this one, of course, forms the basis of how networks work. So which layer of the OSI or TCP IP model does MPLS protocol belong to? Anyone can unmute and proceed to respond. I think John already mentioned something about it, but yeah, I just want someone else to respond to the question.
Okay, hello, good afternoon all.
Hello, good afternoon to you.
Yeah, this is Mr. Fabian.
Yes, Fabian, proceed.
Okay, okay. MPLS is a multi-protocol label switching. So on the OSI model, it belongs to layer 2.5. We say it belongs to layer 2.5 because it shuttles between the data link layer and the network layer. So what basically happens on this layer is label switching. It does not look up to the it does not use traditional IP addresses, so it uses label. Okay, that is why we say it operates between layer 2.5. That is between the data link layer and the network layer.
Okay, thank you. So that is correct.
Thank you.
MPLS works at the data link layer. Thank you, Fabian. And I mean, it works at layer 2.5. That is the layer between the network layer and the data link layer. So we know that we have so many protocols, and these protocols, they serve different purposes, and we need to be able to support all these protocols on our network. Maybe they are for enterprise service, they are for different purposes. We need to be able to carry this kind of traffic on our network without building a separate network for separate service. So that's why with MPLS we are able to carry all these services or to forward them on our network using labels. So it works at layer 2.5. Thank you. Another interesting question is, before we had MPLS, of course, we had the traditional way of forwarding packets in IP network. Anyone who can just explain briefly how the traditional way of packet forwarding in IP network used to be? How were the packet forwarded before we introduced MPLS on the network? How did we perform the packet forwarding in IP network before the introduction of MPLS?
Um, Let me give it a go.
Okay,
So I
proceed.
don't know if it's like a traditional or just how it normally is done is the next the if the routers have the routing table. So when you get a packet, it checks the network it's supposed to go to, and then it checks the next router, and then it forwards it through using the IP by adding the MAC address of the next router and forwarding it to that next hope router.
Okay, thank you. So with the traditional IP routing, of course, nowadays we still have the IP forwarding where we need to perform the route label lookup for every packet that is coming in. So that was the traditional way. You have to perform the route label lookup. You have a packet, you need to decapsulate that packet, check the destination IP, and then you look into your routing table. Remember, the routing table will have many, many entries. And once you've done the longest match, you can now go ahead and do the packet forwarding. And the next hop needs to perform the same process, and the next hop and the next hop. So they need to do all these, and for every packet that is coming in, you have to do this process. So it may not be efficient. Of course, nowadays the routers are advanced. We have high processing power and they can handle it. But again, if you compare with MPLS, it's still much, much efficient. So we also need to discuss why we need MPLS on a network. Of course, there are networks that are operating without MPLS. But again, why do we need MPLS on a network? Why have you deployed MPLS on a network? I think we are all managing some networks. It could be the service provider networks for the telecommunication companies, or you are managing an enterprise for a bank, for a school, even for an office. Why do you deploy MPLS on your networks? Why have you deployed MPLS on your networks? Yes, yes.
Um, because of its speed and number one, traffic, it routes traffic fast. It also supports a number of services, like for example, um, it helps us to efficiently manage the resources because traditional routing, for example, let's say you were using cost, like let's say you have an ISIS or um, a OSPF based network. Uh, because of its design, it prefers cost. But with MPLS, if it prefers cost, that means all the traffic usually will always prefer the least cost. As a result, other parts of the network will remain underutilized. But with MPLS, you can deploy services like traffic engineering. With traffic engineering, you can effectively sweat your investment by employing different techniques so that the whole investment is overall used. And then also, so I mentioned the speed. I also mentioned the effectiveness of managing your asset, in this case, your MPLS network. And then also, MPLS is easy to manage because it's now a standard across the industry. And also it has been it was designed with what do you call it forward thinking. Like for example, right now other service providers are implementing things like segment routing, but at the end of the day, on the forwarding plane, it's still MPLS that is being used. So it's a very flexible technology. That's what I'm trying to say, which was designed for like the future in mind.
That's true. That's very correct. Anyone else with a different perspective? Why have you deployed MPLS on your network? I think John has exhausted many of the reasons, but you can yes, proceed.
Yes, MPLS provides us connection-oriented connectivity over a connectionless data plane. So we can signal switched paths, label switched paths. And in traditional IP forwarding, we only use destination-based forwarding. In MPLS, we can have connection-oriented connectivity, and the LSPs, we can use destination-based IP for forwarding over LSPs, or we can use quality of service, or we can also use traffic engineering to go along a different path than which is dictated by the IGP normally.
Thank you. Thank you. The last person, why have you deployed MPLS before we move to the next question of discussion? Anyone else who wants to contribute to? So I think it's clear the reasons why we use MPLS on the IPRAN network. I mean on the network, even if we are not talking about the IPRAN network. John, and should I pronounce it Yaha, or how do I pronounce the name?
It's Yahya.
Yahya, okay. Yeah, John and Yahya have given an elaborative response why we use MPLS on the network. So you know the traditional IP, it's just forwarding traffic based on the destination and the lowest cost. So all the traffic will always flow as per the cost matrix, but with MPLS, it's giving you the flexibility. You are able to deploy LSPs, the label switched path on the network, and define a specific path that you want your traffic to flow. So you have that flexibility, and even there was a mention of the type of services that you can deploy. So you know that you have different type of services. You have enterprise customers, you have the mobile services. All these services can be deployed on a network that is running with MPLS without any challenges. Okay, thank you, John and Yahya. Another question is which signaling protocols can be deployed on MPLS? So we know that MPLS is using labels, and we need some signaling protocols that will be used to build the label switched path. Yes, proceed.
Okay, we can use LDP,
Can use
and
LDP.
we can use also for the traffic engineering RSVP for traffic engineering,
So we
where
can
you
use.
have the explicit part and the backup part for the traffic flows.
So you have LDP, you have RSVP. Any other protocol?
You can use CSPS also.
CSPF. Any other
Yeah, you
protocol?
can also use BGP,
Yes, you can have BGP
BGP
deployed
as
as the
well.
signaling protocol. Any other?
Signal protocol.
We have the most recent, the one that is the hot topic.
We can also use IGP in segment routing.
Yes, so we have the segment routing that nowadays many networks are evolving to segment routing. Okay, thank you. So another question that we need to understand, maybe, but we may not cover it in this topic, is why do we need VPNs on a network? Why do we deploy VRFs, the virtual forwarding, the virtual routing and forwarding on networks, or the VPNs, virtual private networks? Why do we deploy them on a network? Yes, proceed.
Okay, yeah. Okay, in short terms, VPNs are used to separate maybe for enterprise individual customers networks. Like you create, for in a layman understanding, the way you create VLANs on a switch, that is exactly the way you create VPN instances. Maybe if you have First Bank and maybe UBA bank and other banks, you are carrying their enterprise services through your IPMPLS network. So you create VRFs or VPN instances for them. You create the route distribution that is local to the router, and also you create the route target that is used for the VPN traffic exchange between PEs on the network. So these are basically why you create VPN instances. Thank you.
Thank you. Anyone with something to add? Why we need VPNs? Because the response was very clear. We are trying to isolate services for different customers. Yes, John, you are muted.
Oh, okay. Yeah, but with the nature of VPNs, maybe if we maybe a bit in detail about the RRP, in terms of creating uniqueness and also efficiency of traffic. Like for example, let's say you are deploying centralized VPNs. Um, VPNs can actually be used to manage efficiency within the network because of the RTs and the RTs, the import statements and the export statements. They help in effective management of routes and let's say, for example, BGP, if it knows, if it doesn't understand that it's supposed to import this, so efficiently, it helps the PEs to be more efficient and also manage the CE to PE effectively. So basically, that's how the VPN technology. So the uniqueness and the efficiency that they bring in the routing space.
Okay, thank you. So those are the reasons why we need VPNs on our network. I hope you've gotten it clearly. So we may not discuss about VPNs on this in this episode because you know that is now on service level. So in our next episode, we'll be looking at how do you deploy services on a IPRAN network? How do you deploy mobile services on the network? How do you deploy the enterprise services, the layer 2 VPNs, the VBWS or the VPLS? So that will be the topic of our next session. But in this session, we are just giving you an intro to MPLS so that you understand how MPLS works, and then we will be looking at the seamless MPLS and maybe just the steps you need to do when you are configuring MPLS on IPRAN network. So we already discussed about the IPRAN architecture in our first session. And of course, we already mentioned that in IPRA network, we have different nodes serving different purposes. You have the CSGs, you have the ASGs, you have the RSGs, and you have the different layers from the aggregation to the access layer. And let me get the pen. You have these different services. You can be having an enterprise customer connecting to your device at site, the CSG. You can also have the enterprise customer connecting to the RSG or even the different customer. Maybe this customer and this one, they are from the same company and they need to communicate through your service provider networks. You see, you will not go ahead and deploy separate network for separate customers. We need to use the shared infrastructure that we have already set up. So MPLS will help us to achieve this by allowing us to flexibly deploy different types of services on the service provider network. And again, you have these mobile services. These mobile services should also use the same infrastructure on the network. They should be able to use the same physical setup on the same routers, the same switches, the same fiber connection that you have should be able to carry these different types of services, and that is what MPLS is allowing us to do. So we are not going to build separate networks, separate physical networks to carry separate or different services for different service types. We can share the same infrastructure, we can share the same underlying network, and we will go ahead and deploy different services, different technologies, the layer 2 VPN, layer 3 VPN, all of them can be deployed on top of our MPLS network. So remember we discussed that Of course, before you deploy MPLS, you've already set up your IP address configurations. So you've configured IP addresses on these links. You've configured IGP. IGP, it could be OSPF, it could be ISIS, it could be EHRP. You can deploy any IGP of your choice on this network. So you will already have reachability all the way from the CSGs to the RSGs. And now you go ahead and deploy BGP. So BGP, of course, primarily used to exchange the service routes on this IPRAN network setup. So once you have the BGP in place, you now need to go ahead and think of how do I now deploy the services on this network, the layer 2 VPNs, the layer 3 VPNs. Remember MPLS definitely, the BGP, MPLS, ISIS or OSPF, all these protocols will work together to ensure that your network is operating optimally. So this was just a recap on the IPRAN architecture, just to remind you on the setup that we have from the different services or the different customers that are connecting to our network, to the eNode Bs. You have the 2G, 3G, 4G. Nowadays you have 5G. All those services will be carried on the same shared network infrastructure. So it's very good for the service provider. It's very good for the carrier network. They don't have to build separate network for separate or different services that they are carrying on their network. So let's just do an intro to MPLS to help you understand how MPLS works. So if you have any question, you can just unmute and proceed as we continue to discuss about MPLS. So MPLS, we are calling it multi-protocol. So multi-protocol because it's able to support different protocols on the same layer 2.5. So I've mentioned that we have the network layer protocols. We also have the data link layer protocols. All these protocols can be supported by MPLS. That's why we are calling it multi-protocol. And label switching, it's because MPLS depends on labels. So instead of the IP forwarding, we are using labels to switch traffic from one point to another point. Of course, you still have to have the IP routing table. That is a basic for MPLS to work. You still need to have the routing protocol. You still need OSPF. You still need ISIS, which will help us to get the routes in our routing table. Once we have this routing information, we can go ahead and build now the forwarding information base. And we will be assigning labels to these routes, and we come up with the label forwarding information base, the LFIB. So MPLS is a protocol that uses labels to guide forwarding of packets at a high speed over the IP backbone network. So it's still working on top of the IP backbone network. It's more efficient alternative compared to the traditional IP routing, and it works by mapping an IP address to a short fixed length label. So this is the label. It's a short and fixed length label of local significance. Local significance means that label only has local significance on the router that assign it. Of course, when you start talking about other technologies like segment routing, then the label may not be locally significant. Then it replaces the IP table lookups with the label switching or the label swapping. So we are now replacing the IP lookup. Remember, traditionally, the way IDA has responded, you always have to do the route label lookup for every packet that is coming in, and that one will consume a lot of time, a lot of resources, because you are processing every packet. On MPLS, of course, we have the something like FEC, the forwarding equivalent class. So we'll be looking how that one helps to speed up MPLS label swapping or the packet forwarding. So the MPLS labels are used to establish a logical tunnel. So we will have an LSP that will be established on the label switching path will be established on the IP network, and the packets will be forwarded along that logical tunnel. So MPLS is compatible with different network layer and link layer protocols. Remember, we've mentioned these. because remember it's sitting in between the network layer and the link layer protocol. So it's able to support different types of link layer and network layer protocols. So it can provide public network tunnels for various layer 2 VPN, layer 3 VPNs, and even the EVPN, the Ethernet VPN services that you can deploy on your network. So it's giving you flexibility to deploy different types of services on your network. So that is an intro to MPLS. So why MPLS? So we've already mentioned that the IP technology, it relied on the longest match algorithm that is not efficient choice for forwarding packets. So you need to perform route table lookup, and you decide based on the longest match algorithm. And then we also had the ATM technology. Okay, me personally, have not dealt with the ATM technology, but of course, from the comments, it's a very complex protocol with high deployment cost, which has hindered its widespread popularity and growth. So we need to have a protocol that combines the advantages of IP and also ATM. So this is why we have MPLS. It's combining the best of IP and ATM. Anyone who has used ATM technology, maybe in the audience, anyone who has deployed ATM technology? So I've also not dealt with ATM, but of course this is from the notes provided. So the main benefits of MPLS, it's multi-protocol label switching, which increases forwarding rates. So it's not using the longest match, not doing the VLOOKUP, I mean the route table lookup. So it will analyze packet headers on the edge of a network, not at each hop. And then the packet processing will be shortened. So you are only doing the analysis of packet headers on the edge of the network, and that is it. You can now do the swap operations as the packet is flowing from one point to the other. It supports multi-layer labels, and its forwarding is connection oriented. I think Yahya has mentioned this. It's connection oriented. So it's used to in virtual private networks, traffic engineering, and quality of service. It supports multi-protocol and services and improves data transmission security. So these are just the main benefits of using MPLS on the network. To the next slide. MPLS network structure. So you have different nodes, and these nodes are given different names. You have the LER, we are calling it the label edge router. So this is the device that resides at the edge of MPLS domain. So you have an LER that is egress and the one that is ingress. So this one connecting to a given network, and then this one connecting on the egress. So you have the LER, the label edge router, that is sitting at the edge of the MPLS domain. Then you have the label switch router, that is the LSR. So in the backbone network, you have, for the MPLS domain, you have the LSRs. So LSRs, those one will be the label switch router. They are the one that will be performing the swap operation when the packet is flowing from one network to the other. And then we have the label switching path, which we are calling the LSP. So this is the path along which packets are transmitted on an MPLS network, and it's unidirectional. Unidirectional means it can only go one direction. If you need bidirectional, then it means you need to deploy another LSP between the two devices. So when we have the packets coming into the LER, the ingress LER, the packets will be analyzed. And then this device will add the appropriate labels to them. Remember, on an MPLS network, we can be having a layer of labels. You can be having 2 or 3 labels. So the LER will add the labels that are necessary for this packet to be forwarded from point A to point B. And then we have the LSR. So LSR will swap the labels depending on the destination or depending on the incoming label. So it will check the incoming label. It knows if I get this label, I need to forward this packet using this label. Then we have the egress LER. LER will remove the labels from the packet. So this is the basic network structure of an MPLS network. Do you have any question or comments? Any addition? Feel free to add anything that I have not mentioned, or maybe I've mentioned it wrongly. Any addition, guys? Let's make it more interactive so that you also give me breaks. So that is the network structure. And then when we look at the MPLS architecture, I think Yahya has already mentioned that we have the control plane, which is now the connection oriented aspect comes in. So we have the control plane. The control plane generates and maintains the routing table and the label information. So you know that we have the IP routing table. The protocol that you have will generate IP routing table. It could be OSPF, ISIS. They all have a routing table that is generated on every router. And once we have this routing information, this information will be the best routes will be installed in the routing information base, which we call the RIB. So from the IP routing table, we are generating the routing information base, and this is still on the control plane. And then you have a label distribution protocol. So the label distribution protocol is now assigning labels to these routing information that you have in your routing information base. And once we've assigned the label, so you can have LDP, you can have RSVP, you can have segment routing, any signaling protocol that you will have deployed on your network. So from the label information, from the label distribution protocol, we are able to generate the label forwarding information base, the LFIB. And now this is part of the forwarding plane. So these are the entries that will be used to generate or to forward the traffic as it's moving from one point to the other. The label forwarding information base. At the same time, we still have forwarding information base. Remember, not all information will be coming with labels. Some packets are not coming with labels. So that's why you still need the forwarding information base. We are not doing away with the forwarding information base. We need to be able to support both IP packets and the MPLS packets. So that's why we have the forwarding information base to support the normal IP packets, and then we have the LFIB to support MPLS packets. So this is on our forwarding plane. So we have the forwarding plane. This forwards IP packets and MPLS packets. So we have the forwarding information base used to forward common IP packets, and then we have the label information base that will be used to forward MPLS packets on our network. Any question? So that is how MPLS is able to handle the control plane and the forwarding plane when it's processing the packets. Then we have the forwarding equivalent class, FEC. So FEC, this is just a collection of packets with the same characteristics. Same characteristics could be the packets that are coming from the same source and they are going to the same destination. Yes, someone has a comment? So you have packets coming in with same characteristics. It could be same QoS class, it could be same source and same destination, same port. So you are able to classify these packets into what we are calling forwarding equivalent class, FEC. So packets of the same FEC are forwarded in the same way on MPLS networks. Packets of the same FEC are forwarded in the same way on an MPLS packet. And how do we identify FEC? So we can use source address, destination address, the source port, destination port, and even the VPN. This one will help us to classify packets into some classes, and the ones that will have that will be the same class, they will be handled or forwarded in the same way on an MPLS network. How it works? So routers in an MPLS network will assign labels to packets based on their characteristics. So you've characterized packets into different classes, and then you go ahead and assign labels to these packets. And the characteristics we've already mentioned: destination prefix, the source prefix, or even the QoS requirements. So that's why MPLS also helps in improving on the quality of service or the QoS of different services. So we are able to assign different QoS values, and then we can treat them differently depending on the characteristics or the requirements of these QoS classes. So packets with the same characteristics will be forwarded through the same LSP. Yes. Yes, someone is raising their hand.
Hello, Martin.
Yes. Yes.
Sorry, I just get the. I just joined you right now. Sorry.
Yes.
I'm so the I don't have enough idea on that on what you are doing. I want just to get maybe the kind of the idea in general on what we are doing. I want to know. My question is that I want to know where can we find the MPLS in the network, at what level, and what is the purpose of the MPLS in the network, and if we don't implement that technology in the network, what will happen? What is the failure and the advantage?
Okay. You're welcome to join the session. Anyone who can respond, I think we've already answered those questions. Maybe someone from the audience can respond. Where do we find MPLS in a network? Why do we deploy MPLS? And again, if you don't MPLS, I think you just need to explain on the benefits of having MPLS on a network. Anyone who can quickly respond to that before we continue? Yes, Fabian. Fabian, we can't hear you. Are you able to hear Fabian? Yes, Innocent, you can proceed. Fabian, we can't hear you.
Okay, we can deploy MPLS between the enterprise network and between the ISP network. Why do we need to employ MPLS? We said that MPLS is more efficient in transmission, it has high speed, it is easy to manage, it supports a number of services whereby, as we mentioned here, you can use some protocols such as traffic engineering, sometimes segment routing. Also, we have said MPLS is easy to manage. Yeah, that's why we need to deploy MPLS. But if we not employ MPLS, what we are going to face is our network is going to be very slow because we will be using the traditional IP forwarding, whereby each router has to pass the packet and use the IP lookup mechanism. But if we are using MPLS, it means the routers will be just swapping the labels and the forwarding process will be very fast. Yeah, that's all.
Thank you, Innocent. I hope the response is very clear.
Yes, yes, of course, Martin. The answer is clear. Is clear. Okay, no problem. I think during the session, maybe I will be understanding maybe more.
Yes,
No
yes.
problem.
And
Let's
when we
follow.
upload the recording, I think initially we have discussed about the reasons why we need MPLS, and there were clear definitions, the same way Innocent has given the response. So once the session is uploaded, maybe you can go through it because we've already covered a lot on the basics of MPLS, and then it will help you to understand why we need MPLS and where it is deployed, the benefits, and how it works.
Okay, thanks.
Okay, thank you. Any other question from any other member? So we were talking about FEC packets with the same characteristics being forwarded on the same label switched path, which we are calling the LSP. So the LSP, that is the tunnel, the logical tunnel that will be deployed on an MPLS network from the LER to another LER to ensure that the packets are forwarded efficiently on the network. So this one will help to, let me pick the pen again. So it will enable efficient and predictable forwarding of traffic across an MPLS network. Remember, we talked about deploying this tunnel, the traffic engineering. So with traffic engineering, you are able to control how your traffic flows on the network, and that one makes it predictable because you know how your traffic is flowing across your MPLS network. So this one also helps to optimize on the resource utilization and QoS management. So you are able to provide preferential treatment on the services that you choose. Maybe you have some special services or you have some special customers on your network. You can give them preferential treatment. So the LSPs will be established to carry traffic belonging to specific FECs, and each LSP is associated with a particular forwarding equivalent class. So it will ensure that all packets belonging to that FEC are forwarded through that specific path. So they will follow the LSP end to end from point A to point B. Now, when we talk about MPLS label, so we already mentioned that this is a short fixed length, 4 bytes long, so it's 4 bytes, and it's only locally significant, meaning that if a router uses this label, if you have a connection, maybe you have 3 or 4 routers, you have one router, you have another router, you have another router, and these routers are connected. If this router has assigned a label, maybe 300 or any other label, the same label 300 can be used on this router because the labels will be locally significant. But when you start talking about segment routing, as I've mentioned, now there are some globally significant labels, but with the normal MPLS, the labels are only locally significant, and it's 4 bytes long. It identifies an FEC to which packets are belonging to. So it's an identity of an FEC, the forwarding equivalent class. So a label will be assigned to an FEC. And definitely we'll have, if you are doing this based on the destination, remember we could be having so many packets that are coming into going to the same destination. So you don't have to perform the lookup the same way we did with the IP routing. No, you just check on the FEC. If this packet is belonging to this FEC, you already have the label. You perform the swap or the push operation, and that is it. The packet is able to be forwarded across the network. So once you've introduced an MPLS label, it means the MPLS packet will have an additional 4 byte. So remember, initially you had the link layer header, the MAC addresses, and then you had the layer 3 header, the IP address, and maybe the TCP head, the layer 4 header. So you are now introducing an MPLS label between the link layer header and the network layer header. So you've added an additional 4 byte data on that MPLS packet that is now being forwarded on the network. So once you've inserted your MPLS label, these are the fields you expect in MPLS label. So you have the label. So you have the label itself, which is 20 bits long, and then you have EXP. EXP, this is experimental field. It's 3-bit long, and this is what is used for the class of service. Remember, we've talked about QoS. So if you are having packets coming in with a different class of service, you are able to process them based on the QoS value that they are coming in. So you have 3-bit, which means you can have 8 MPLS classes. Of course, when we look at the QoS on IPRAN network, we will dive deeper into these different 8 classes that we are talking about in the EXP field. And then you have the S field. So this one helps us to identify the bottom of a label stack. Remember, there is always like you can have multiple labels on an MPLS packet. You can be having a layer, a chain layer of or a stack. You can be having 2 or 3 labels. So the S bit will help us to identify which one is the bottom of the label stack. And then we have the TTL. So this is the time to live, and this is the same as the TTL in the IP packets. So this is how an MPLS packet will look like. You have the link layer header, you have the MPLS label, which consists of the label itself, the EXP, the S, and the TTL value. The label space. So the label space, this one gives the range. So you have some special labels. You have the explicit null, you have the implicit null, you have the label that are reserved. 4 to 13 are reserved. You have 14, which is the O&M router alert. Then you have, so if you are configuring static LSPs, static label switched path on your network, you will be using this range of labels, 16 to 1023. So this one will be used for static LSPs. And then you have 10 to 24. This one will be shared by the dynamic signaling protocols like LDP, RSVP, or multi-protocol BGP. So that is the label space. The label operations, we've already mentioned about them. So there are 3 main operations. We have the push, we have the swap, and the pop. So push means you are adding a label. Swap means you are dropping the existing label and you are replacing it with the label that you have. And this one happens on the label that is on the top of the stack. And then you have pop, means you are removing the label from the packet. You are removing all the label or the egress or the remaining label on that MPLS packet. So you are doing a pop operation. So we have the concept of PHP. This one you can read about it. So you can see that we are getting an IP packet. This one could be the customer. You are getting an IP packet on the egress LSR or the LER, and then you will perform a push operation. So you are adding a label L1. Once you've added a label L1, you see on this the P router, you are doing a swap operation. So you keep performing swap operation on the LSR until the packet arrives on the ELR LSR, and then you perform the pop operation. But if you have the penultimate hop popping, then it will be performed on the penultimate LSR. So the way this packet is forwarding, that is what we are calling the label switch path. The label distribution, we've talked that you have some. Yes, yes.
Could you repeat again about penultimate?
Penultimate hop popping. I think someone from audience can explain that, so that anyone who can explain the penultimate hop popping. Yes, yes, proceed. Penultimate hop popping.
Okay, hello.
Yes,
Penultimate hop popping
yes,
is okay. Penultimate hop popping is PHP. So in IPMPLS, it is called last but one. Okay, it is a router maybe that will remove a label. After it has removed that label, you have an IP, okay, that the next router will receive. So it will remove the last label of the MPLS.
Anyone with anything to add? PHP, not the coding language, but in networking, the PHP in networking. So with penultimate hop popping, yes, yes.
Yes, it is an optimization so that the last router doesn't have to do two lookups, a label lookup as well as IP header lookup. So the optimization says that the second last router performs the label lookup and pops the label and forwards the native IP packet so that last router does not have to do two lookups, a label lookup and a IP header lookup. So it only performs IP header lookup. We can say it is an optimization.
Yes, thank you, Yahya. So I hope you've gotten it clearly. Penultimate hop, of course, this is the second last hop. So you can see in this setup that when we talk about penultimate hop, then this router will be the penultimate hop. If this router just removes the topmost label and forward this packet to the egress LSR, this egress LSR will have to perform two actions. The first one, it has to remove the topmost label, and again it has to do the IP table lookup. So it's performing two actions, and actually it doesn't require that label information unless it's on a specific application. Some specific applications, definitely you still need to maintain that label until the last hop. But in this scenario, the egress LSR can only perform the IP lookup. So if this router, the penultimate hop, drops the label stack, it means it's forwarding an IP packet to the LSR, and then this router will only perform the IP lookup. It doesn't have to perform both the label lookup and IP lookup. So it's making it's like we are reducing some pressure from that device at the edge, so that it only performs one action, which will be IP lookup, and then it will forward the IP packet to the destination CE. I hope that's clear.
Yes, Martin, it is clear, but I have a question there.
Yes.
Uh, are there scenarios in which their MPLS can be deployed without having PHP?
Yes, yes, of course, of course. You can, you see, as we've mentioned, this is just a mechanism to try and reduce the pressure on the end device, the egress LSR. So if you can reduce, maybe this is a low end device, or sometimes even from the explanation, uh, you see, this device, if it receives this packet, it has to perform two actions. The first action is to remove the label, right? the label that came in from the penultimate LSR. Once it has removed that label, it still has to perform the route table lookup. So yes, this device can perform it. The network will function okay, but it's not that efficient enough. So you can have a network without PHP, but if you have PHP, then it will be more efficient in forwarding the packet from source to destination. Hope that's clear. Okay, any other question? So we were talking about the label distribution. So we've mentioned that MPLS uses labels to forward traffic. So we need to have a way in which we can distribute these labels on an MPLS network. We need to have these labels distributed on the network so that the routers will be able to know which label will be used for what FEC. So this is what we are calling the label distribution. And for the label distribution protocols, we have different, of course, sometimes we call it the signaling protocols. We can have LDP, we can have a resource reservation protocol, the RSVP or RSVPT with traffic engineering. You can have MPBGP, the multi-protocol extension for BGP. And then you can have segment routing, for example, in SRMPLS, where you are using segment routing as the signaling protocol. And then these protocols will be used to assign labels to the different FEC that you have in the network. So that is basically it about label distribution. You can read about it further. You can go and check on LDP, RSVPT, MPBGP, segment routing, so that you understand how they are able to distribute labels on a network. Any question? So the forwarding process, this is something that you need to understand. Remember, we've mentioned that the MPLS will forward packets by doing some operations, the pop, the push, the swap. So you have a packet. First, we need to do the label distribution. So label distribution, this is the destination network. This destination network needs to be accessed from the ingress device. So this device will send a message to this transit router telling it that if you want to reach this network, use this label. What does 3 stand for, by the way? We talked about some special labels. 3 means what? Anyone who can remind us? Which type of label is number 3?
PNP.
Okay, anyone else? Label number 3. You can even Google, guys, and respond. It's also part of learning. Label number 3, what does it mean in an MPLS setup?
Hello?
Yes, Fabian.
You said level number what? 3?
Yes.
I think that's implicit null, if I'm correct.
Okay.
Yeah. I've taken it.
Okay, you can mute, Fabian.
Yeah.
So, back to this slide, we have number 3. This is the implicit null. So we call it implicit null, and it's used for, so Isaac, you are right also, it's used for PHP. But the label itself, we call it implicit null label. So if this guy is sending label number 3, it's telling the penultimate hop that if you are sending me traffic to this destination, this network is connected to me. Do PHP. and remove all the labels and give me an IP packet so that I don't have to perform the label popping from that packet. So that is what the label number 3 does. It's allowing the transit router to perform PHP. And then this transit router has to forward the same. Remember, we have label distribution protocol deployed. So it has to notify this other transit router that if you are sending traffic to 3.3.3.3/32, use this label, label Y. And again, this router tells the ingress router, if you are sending packets to 3.3.3, use label Z or Z. So this is on the control plane. They are distributing labels based on the destination address. Once they have, so you can see that the label distribution it's downstream, but the packet flow it's upstream. So now we have a packet that is destined to 3.3.3. This packet is coming in on this egress router, and this router has a label. It got a label from this, maybe I call it this router 2. And this one, I make it router 1. So it got a label from router 2 telling that if you have to forward packets to this destination, please add label Z. So this router does a push operation and adds label Z on that IP packet and forward this to router 2. So when the packet arrives on router 2, this router 2 has received a label packet, and that label has label Z on that packet. And remember, this router, they have a mapping. They have a mapping between the incoming label and the outgoing label. So router 2 will need to check, if I receive a packet coming in with this label Z, I need to add label Y. So it will do a swap operation on this packet, remove label Z, add label Y. And then this packet arrives on our PHP, on our penultimate hop. This is, I call it router 3. So router 3 has received a packet coming in with label Y, and it has a mapping that if this packet is coming in with label Y, you need to do PHP. Remember, it received label number 3 from the egress router. So it will remove the labels, and of course it's adding label 3, but in reality that one is just like no label on that packet, and it forwards the IP packet to the egress. So the packet is forwarded, an IP packet is forwarded to here. This router performs the route table lookup and forward the packet to the destination, which is 3.3.3. Do we have any question before we talk a little bit about the seamless MPLS? So the application scenarios. So we have different application scenarios. You know that you have the MPLS network, so we have different functions. We can have the customer edge. I know this one you're already familiar with. You have the provider edge. You have the PE routers. So on such a IPRAN network, we know that we have the CSGs, we have the ASGs, we have the RSGs. So depending on where the service is connected to, all these different types of equipments on IPRAN, they can be seen as the PE routers, the provider edge routers. Remember, they are the ones that are connecting to different customer edge devices. This device is connecting to a BTS. A BTS, that is a customer edge device. We could be having an enterprise customer here connecting to this CSG. This is still a CE. So you can see all the devices on IPRAN network, we can view them as the PE if they are connecting to any customer. But again, if you look at this setup, you realize that, for example, when this customer, this BTS is connected to this CSG, the traffic will be forwarded along this path from this CSG to this RSG. So when the traffic is coming from the CSG to the RSG, the intermediate devices, they are all acting as the provider routers. They are all acting as the provider. They are part of the MPLS backbone, and they are the ones that are doing the label swapping when the packet is flowing from one BTS to the controllers. The RSG is also a PE device, the provider edge device, because remember they are connecting to the controllers, the BSC, the RNC. Those can also be seen as customers in the network. And any other intermediate device that is on the forwarding path, then we are seeing it as a provider device. Any comment? Any question?
Can you repeat on the description of all IPRAN devices mapping with MPLS devices?
Okay, so we have, let me see whether this one will work. So first we have these functionalities, right? We have the customer edge, the PE, and then these PE devices, of course, we can be having the P devices. The intermediate devices, we call them the B devices. The device that are connecting the device on the edge of a service provider network, we are calling them the provider edge. And then the customer devices, this one we can see them. So any other device that is connecting to our IPRAN network, any other third-party device that is connecting to our IPRAN network, we are seeing it as a CE. So this BTS, it's a CE. This controller, they are all CEs. They are all customer edge devices. This enterprise customer, it's also is also a CE, the customer edge. And remember the function of this provider edge. These are the ones that are maintaining the VPN routes. And these devices, we are calling them the provider edge. So in a typical IPRAN network, all these CSGs in MPLS network, they will be acting as provider edge devices. All these devices, because they are connecting to either BTS, they are connecting to a customer, an enterprise customer, or they are connecting to a controller. So they can all be seen as provider edge devices. But now when we look at just one device, this device that is connecting to a BTS, for the traffic to flow from this BTS to the controllers, it has to flow through these other intermediate devices. So these intermediate devices, in the perspective of the traffic flow from this BTS to the controller, we can see them as the P devices. Because remember, they are just performing the swap operation when traffic is flowing from this BTS to the controllers. So we can see them as our P devices in the network. But at some point, they are also acting as PE devices to other customers in the network. So it depends on where the device is located. It depends on which services are connecting to this device. So they can either be provider edge or they can be the P, because they are part of the MPLS backbone network, and they are part, when you are forwarding the traffic, of course, they are also forming part of that label switched path that is established from the source to the destination. Innocent?
Yes, I got you, Martin.
Okay. So that is it for an introduction to MPLS. Any question, guys, before we look at MPLS for IPRAN and dive into seamless MPLS? Kindly remember, if you are yet to subscribe to our channel, also the link is available, or you can just search Life Technologies on YouTube, and then you will find all the recording that we have on our channel. We have the recorded previous sessions. We also have other videos that are published on our channel. And yeah, you can also share with your connections. That is a way of supporting Life Technologies. So when we look at MPLS for IPRAN, we've already mentioned that MPLS has benefits on a network. And we know that the IPRAN network, we have different layers. So we have access, we have aggregation, we have the core. And all these devices are participating in the packet forwarding on the network. So if you don't deploy MPLS, it means these devices, they will be using the normal IP routing, which is not efficient enough. And again, we've also mentioned that MPLS allows us to flexibly deploy different types of services on the same existing infrastructure. So we can easily deploy flexible services for the mobile backhaul. Remember, IPRAN is primarily acting as the mobile backhaul network. So we are connecting or carrying different services from the mobile stations to the mobile controllers. So in IPRAN, of course, this is purely IP-based wireless access network. And we can deploy MPLS on this network so that we can enhance the data transmission efficiency, especially in wide area networks. So first you have your IPRAN network that is purely IP based, and then you are bringing in MPLS so that you can enhance the data transmission efficiency on the IPRAN network. So the IPRAN will end up having IP MPLS, so it will now transition from being purely IP to now IP MPLS at the different layers of the network. So traditionally you find that we could have the access layer purely deployed as layer 2, where you have these devices, the CSGs are configured as layer 2 devices. You just need to pass the VLANs and that is it. But with the current setup, we deploy MPLS from the access to the aggregation and even to the core. So we are deploying MPLS on the entire network. And then we are able to have the flexibility of deploying different technologies. We can deploy layer 2, layer 3 technologies on our network without any problem. We can easily scale our network, and we can flexibly deploy different types of services on our network when we deploy MPLS. So we have what we are calling seamless MPLS. This is a very complex topic, but yeah, let's try it. So seamless MPLS, sorry. When we talk about seamless MPLS, we only have 8 slides remaining. This is just a network architecture that extends MPLS capabilities to access networks. So you know that we have, let me use the pen again. You have the access, you have aggregation, and you could be having the core, depending on how you've set up your layer. And we have different services that are connecting to this access network and also the core network. For example, you have the eNode Bs, the BTS, the Node Bs, the Gnode Bs for 5G. You also have wholesale services, the enterprise list lines. They are all connecting to your access layer. So you need to have some way of seamless networking so that you can have these customers communicating without any problem using the same network that you've already set up. Remember, when we started, we mentioned that you don't need to build a separate network for separate customers. So that's why you need some seamless networking. so that you can seamlessly carry different services on the same underlay network without the need to set up separate network for separate customers. So we are extending the MPLS capabilities to the access networks, enabling end-to-end label switched path. Remember, we talked about the LSPs. So we are able to establish LSPs from the access to the aggregation and the core, which will facilitate flexible and scalable service deployment, especially in the IPRAN networks. So how does seamless MPLS work? It will establish end-to-end LSP that spans across access, aggregation, and core layers of the network. And all services will be encapsulated using MPLS. So any services that are being carried on this network, we are encapsulating them using MPLS. And there is seamless transmission of these services along the established LSP through the 3 network layers. So you have an LSP that is established from the CSGs to the RSGs so that we can be able to forward traffic from one point to the other. Sometimes, of course, you have a network that is spanning multiple autonomous systems. So we can have intra-AS seamless MPLS. We can also have inter-AS seamless MPLS. We can also have the hierarchical VPN. So those are just some technology that are being deployed with MPLS coming into the play on IPRAN networks. So it's just a design concept. It's not a specific protocol. It's just a design concept. It's just allowing you to deploy MPLS from core to the access layer. So we've already mentioned it's establishing end-to-end LSPs, and all the different types of packets or different types of protocol will be encapsulated and forwarded using MPLS labels. So you have a unified way of carrying these services on your MPLS backbone network or your service provider network. So seamless MPLS still, it's using the existing IP MPLS technologies, and you don't need any new protocol extensions for you to be able to deploy this protocol on different vendors. Remember, we have different vendors: Nokia, Huawei, Juniper, Cisco. All these vendors, they support the seamless MPLS. So if you are having an IPRAN network with devices from ZTE, you can go ahead and deploy seamless MPLS without any problem. And remember, MPLS, of course, it's separating the service plane from the transport plane, enabling independent service provisioning and management. So benefits for IPRAN, why do we need MPLS? I mean the seamless MPLS scalability. So it's allowing for efficient deployment and management of large number of base stations and services. Flexibility, you can easily deploy different types of services like voice, broadband, carrier class services, even the fixed mobile converged services on the same MPLS network. Simplified management, we have reliability, cost effective. Remember, you are not building different infrastructure for different services. And then you have simplified service deployment and management. So, and you can use other technologies like BFD, FRR, tunnel protection when you have MPLS in your network. So the key technologies, of course, before you deploy MPLS, the seamless MPLS on your network, you have to have some kind of protocols deployed. So you need BGP, you need MPLS LSPs, so you need the label switched path, which will be used for encapsulating and forwarding traffic across the network. You need the MPLS O&M that will provide mechanism for monitoring and troubleshooting the network. If you are deploying different MPLS services like the layer 2 VPN, you also need to be able to monitor these different types of services, and then protection and recovery. So you can have the fast reroute, you can have BFD, You can have all those different technologies deployed to ensure that you support rapid protection, switching, and recovery mechanisms on your MPLS network. So of course, we've talked about deploying tunnels on the network. So these tunnels will be able to switch whenever there is a failure on the network. They should be able to switch quickly so that you reduce on the downtime. So when we talk about intra-AS seamless MPLS, you still need to have the control plane, and you still have to have the data plane. So for the intra-AS seamless MPLS, remember you still have the access aggregation, and sometimes you have the core layers. In this setup, you can just take the ABR, because many times on the IPRAN network, you will find that these devices, they aggregated onto one device we call the RSG. So we'll just have an RSG that is acting as the ABR, or the mobile aggregate service gateway. So you will have to deploy some protocols starting with the IGP. So remember, we've already discussed how to design ISIS for IPRAN network. So you can just revisit that session and watch it if you missed how to do design and configuration for ISIS on IPRAN network. You can still use OSPF. It won't matter. You can use any dynamic routing protocol that will be able to support other functionalities. Once you've deployed OSPF, remember these are all in the same autonomous system. So they are all in the single AS. This is a single AS. So you also have to establish BGP. We've already talked about BGP deployment on IPRAN, and we also had a lab on the same. If you missed it, you can still check it on our channel. So you will have to establish BGP sessions between CSG and the ASG, also ASG and the RSG. So those are the protocol that will be working on the control plane of a network that is deployed with seamless MPLS. And then we have the end-to-end BGP LSP that will be established between the CSG and the RSG. So remember, I've said that many times we have these devices aggregated into the RSG, the radio site gateway. So you will have tunnels established from the CSGs to end-to-end LSPs established from the CSG to the RSG, so that we are able to forward these services from the radio side to the controller side. For the BGP, I've already mentioned you establishing BGP sessions from the CSG to the SG. The SG establishes BGP session to the RSGs in the network, and you can have the route reflectors deployed for route propagation on the network. For the forwarding, so under the intra-AS seamless MPLS forwarding plan, remember you have an LSP that is established from the CSG to the RSG. So that is the LSP that will be used to forward the packets. And the labels will have been propagated from there depending on the traffic flow. So if the service is connecting to the E node B and you need the controller to be able to reach it, remember we need to establish an LSP that is bidirectional from the CSG to the RSG and also RSG to the CSG, and then we'll have end-to-end forwarding plan, or the forwarding path that will be deployed on the network. So the same way we've been discussing about the actions performed by MPLS. So the CSG, definitely, if the CSG is trying to access the S gateway or the MME or the RNC or the BSC, then CSG will push the BGP LSP label and the MPLS label in the sequence into each packet and forward the packet to the aggregation node. But of course, as we've mentioned, we could be having other CSGs in the forwarding path. So these other CSGs will also be performing the swap operation, removing the topmost label and swapping it with their own label that they have assigned for the packet forwarding. So when the packet is on the SG, the SG will remove the access layer MPLS labels from the packet and swap the existing BGP LSP label for the new label. So it's just performing a swap operation. Remember, in this sense, this one is just an LSR, a label switched router. So it will perform the swap operation. And then the packet goes to the ABR. The ABR can perform PHP. That the ABR in this case could be remember I mentioned that this one it combines the function of the RSG. So we combine MSG and the ABR into the RSG. So if the packet is coming from the node B to the S gateway, then the AGG can be the PHP. So it can perform the penultimate hop popping and then send an IP packet to the RSG, and the RSG will now forward the IP packet to the MME or the S gateway, and the reverse path will still be the same. So you have the VPN label that is identifying the exact service or the exact customer. You have the BGP label. You still have the MPLS tunnel label that will now be used to forward the packets on the MPLS network. So this is for intra-AS, same autonomous system number. For inter-AS now, you have a network that is spanning multiple autonomous system numbers. You have to again deploy different protocols. You still need to have ISIS or SPF for reachability. You still need to go ahead and deploy BGP between the CSG and the ASG, ASG and the RSG. And you need to go ahead and configure now eBGP. Remember, these one are in different autonomous system numbers. So you need to configure some routing protocol between the two. So we use eBGP, and then you have in the ASY, you still have to go ahead and also deploy these protocols, ISIS or SPF. So the good thing is you can use ISIS in one AS, you can use OSPF in another AS, depending on the requirements. So again, we will have to do the label assignment. So the labels will be assigned, and this is the control plane whenever you have inter-AS seamless MPLS working for your inter-AS communication on the network. So when the packet is now being forwarded for the inter-AS seamless MPLS, again, the CSG will have to push a label. Remember, we are still establishing an end-to-end LSP from the CSG to the MSG. As much as they are on a separate AS, we still need to establish the end-to-end forwarding path. So the CSG will still do the same. It will still have to add some labels on the packet, the BGP, the MPLS, and the VPN label on the packet. The SG will perform the same function. It will remove the access layer and add its own label. Now the SBR, which is the RSG, will receive the packet and it will swap a BGP LSP label for a new label and adds a core layer MPLS tunnel label to each packet, and then it will forward to the other end. And that one facilitates the end-to-end flow of the packet from one autonomous system number to the different autonomous system number. I know we have these setups in our network. We have maybe in one region you have a controller, in another region you don't have a controller. So these packets should be able to flow from the region without a controller and span across that region that has a controller. So in that setup, that's where you need inter-AS seamless MPLS, because you still need these inode Bs need to reach the controllers in the autonomous system number, in a separate autonomous system number or in a separate region. So this is where the inter-AS seamless MPLS comes in. So whenever there is a network issue, whenever there is a failure on the network, you always need to remember, we've talked about the flexibility of deploying tunnels. That label switched path will be able to switch. Maybe there is a link failure If there is a link failure, this traffic should be able to switch and use the redundant path. Maybe there is a link failure in the aggregation, still same. The traffic should come all the way. That's why when we mention, like when you are doing your configuration, you always have to consider the network redundancy. If you are configuring BGP, definitely you need to configure BGP to this AGG1 and also to this AGG2, the aggregation node 2. Same way for the aggregation, you always have to establish redundant BGP session so that there is a primary path and there is the backup path. So if there is a node failure, still same. There is always a path that we can use to forward the traffic from point A to point B without any problem, without any downtime in the network. Maybe just a flap for a few minutes, but again, the network will converge and we'll have the service restored. So for the configuration roadmap, remember you need to still start by designing the IP addresses. You need to start by designing your IGP SIS, which we've already discussed about. You need to configure the IGP, you need to configure BGP, and then you can now deploy MPLS on the network. So on MPLS, we have what we are calling the LSRs. So LSR, this is a very unique identifier in an MPLS domain. And many times when you are setting up your network, you always have to use the loopback IPs because the LSR should be unique. So that's why many times we use the loopback IPs to configure the LSR ID. So you need to do a proper planning for the LSR IDs. And before you configure any MPLS functionality, you always have to configure the LSR ID. If you try to configure MPLS without configuring LSR ID, the router will not accept. So you need to configure the LSR ID first. And once you've configured the LSR ID, you can go ahead and activate MPLS globally on all CSGs. So you can now go ahead and configure MPLS on the routers. And of course, if you intend to configure some different MPLS services like Layer 2 VPN, you also need to activate MPLS L2 VPNs on the router and any other functionality that you plan to configure on the router. Once you've done that, you need to configure MPLS signaling protocols. You choose whichever you want to use. It could be LDP, it could be RSVP, it could be RSVP-TE for traffic engineering. So you need to configure these parameters. And once you've done that, you can now activate MPLS on all interfaces. So when you are setting up in this setup, if you are setting up your network, you will have to activate MPLS on all these links. And that is a very straightforward configuration. You need to activate MPLS, you need to activate MPLS LDP if you are using LDP as your signaling protocol. You need to activate MPLS RSVP if you are using RSVP as your signaling protocol. If you fail to configure MPLS on one of the interfaces, the services will not switch whenever there is a failure in the network. That's why you need to check and confirm that as much as you have redundant links, you have still gone ahead and activated MPLS and MPLS LDP or MPLS, whichever signaling protocol you are using. Those protocols should be activated on all your links. And then you can have seamless failover of traffic whenever there is a fault. If you don't, if you fail or you forget to activate MPLS or MPLS LDP, remember, you won't be having labels and then your network will be down. As much as the link is up, the link will not be able to carry the traffic. So these are the configuration roadmap, how you will configure MPLS on IPRAN. And that is it for today. Any questions? Any comments? Any clarifications? The floor is open. Any question, guys? Are we still there?
Yes, we can
Innocent.
hear you. Yes.
Yes, Innocent.
Yes, Martin. We have seen the importance of using MPLS as a transmission protocol, but what's the difference of using various signaling protocols? What a significant change does these signaling protocols bring? What's the difference of using LDP, RSVP, or uh, the one which is you said is famous right now, the segment
Segment
routing?
routing.
Yes. What's the difference?
Okay, anyone, I will give it to the audience. Anyone who can respond to that. The question from Innocent, what is the difference between these different signaling protocols? Why do we use RSVPTE and not LDP? Or maybe why are we now moving to segment routing? Anyone can respond to the question from Innocent? Why do we need signaling protocols at the first place, and what is the difference between these different signaling protocols? Anyone who can give it a try? So when you talk about LDP and RSVPT, of course, there is a very clear difference. LDP, its support for traffic engineering is limited, but RSVP, at least, it has support for the traffic engineering. So whenever you are going for the traffic engineering, definitely you will have to deploy the RSVPT as the signaling protocol or any other protocol that supports signaling. For the segment routing, of course, segment routing, we call it the source routing. So we don't, with the segment routing, we are able to signal an end-to-end path just from the source. Like if you are receiving packets and this packet has all the routing information that you need, you don't need to do the lookup that we have been talking about. So segment routing, of course, that one, it's aimed to support the new features like network programming and many other like the SDN, because when you have the SDNs coming in, I mean the software defined network, you need some technology that can easily support that software defined networking. So the SDN controller can be able to calculate the path, and then it will deliver this information to the ingress. So all this information can be given to the egress, I mean the ingress node, the edge of the network, and then this information is added on this packet, and the packet can now flow from point A to point B. So of course, segment routing also supports traffic engineering, but LDP is limited in terms of network, the traffic engineering that you can do with LDP. I hope I've tried answering your question, Innocent. Okay, thank you. Any other question, guys? Any other thing that we need to clarify, even from the previous sessions? You can ask. Any question? Any comment? Anything outside MPLS that you need clarifications on?
Maybe Martin, I can ask about
Yes.
why ISIS is mostly preferred as an IGP rather than OSPF in IPRAN networks.
ISIS first, the scalability. You see, the service provider network always spans multiple regions or has many routers that we need to deploy on the network. And remember, with OSPF, we have the backbone area, the area 0, right? And with the backbone area, it means, like, of course, you can go ahead and deploy the virtual links, but again, it's never the best practice. So you have your network. If you deploy SPF, you've divided them into separate areas. You need to ensure you are connected to area 0 at some point. Sometimes you can even have multiple area 0, but you connect them in an OSPF setup. But now ISIS doesn't have such limitations. Whenever we have configured ISIS on the network and we use, for example, level 2. Remember level 2, that is like the backbone area in OSPF. We can easily scale our network. We can easily ensure that we have communication throughout the entire network without having such limitations as the backbone area, or because we cannot have the entire IPRAN network in backbone area. We cannot deploy the entire network into area 0. And with this service provider network, it's too huge. At some point, definitely, you need to think about deploying these virtual links, which are not best for the network. And again, when you look at how the network is evolving, we are talking about segment routing. If you have a network that is using ISIS, it's very easy to evolve into segment routing, because ISIS already has extension that you can use for segment routing. If your network is evolving to IPv6, it's very easy to use ISIS as the routing protocol. You just need to activate that ISIS for IPv6, and that is it. For OSPF, if you are using OSPF, it means you need to go ahead and deploy OSPF version 3. So you see the limitations of using OSPF compared to the ISIS protocol. So it's more scalable, very easy to extend, and support new protocols like segment routing, IPv6, if you compare it to OSPF. Anything I've forgotten to add, anyone can also support on that. Any other question? We have 2 minutes remaining, and then we will be done with our session. I think today we've kept time. Any other question, guys? Any comment? Okay, then that is it for today. Thank you so much for joining this session, and the recording will be shared on our YouTube channel. Again, if you are yet to subscribe, just remember to find that subscribe button, and stay tuned in for more upcoming videos. So I will upload the recording and then I will share, and also I will share the slides in the WhatsApp group. If you are not in the WhatsApp group, you can join the WhatsApp group, and then you will get the slides also from your email. I will also share on the email, and yeah, we see each other again in our next episode. So the next episode, we will now start discussing about service deployment. We need to know how mobile services are deployed on the service provider network. We need to know how enterprise services for different customers are deployed on the service provider networks. And finally, we will look at the quality of service. Thank you so much for joining, and yeah, have a good weekend ahead.
Thank you.
You're welcome.
Thank you. Hello, I'm Oju.
Thank you.
Thank you. Thank you. Thank you. Thank you.
You're all welcome.
Thank you. Thank you. Thank you.
Hello, Martin. Yes. Sorry for. I know that we are at the end.
Thank you.
Just one precision. When you are sharing the date and time in the group, try
Yes.
to do it with more precision, like time encoding the GMT GMT time, because we are lost. You can't see. I can't see my brother now. He just connect now because from our side, the 2 p.m. The
Yes.
2 p.m. Yes, it's not the same with your time. So we are getting confusion. For the next time,
Yeah, but when I
let,
send the notification, normally I put EAT. So
ah,
So, hello, Farezo.
yes, yes, Eric, yes.
So that means from being in Republic of the Congo, you can join by 12 p.m.
No, even 12 p.m. They start. I can see the in the group. They start at 11. You can see the time where he share the link. Then they start. I can see the at 11. 11, yeah.
yeah, okay, maybe because I can't cover all the time zones, but again, it's a good suggestion. I will try to see how to go about it.
Okay. I know, Eric. You're right. At 12. At 12. Okay, good. I can see at 12. Okay. No
Okay,
problem, Martin. Yes.
okay,
No
okay,
problem.
okay. Okay, thank you guys, and yeah, let's see each other in our next session.